Welcome to This Explainer. So today we're tackling something you probably haven't thought a whole lot about since high school math class. But honestly, it is an absolute secret weapon in human history. We're talking about the humble triangle. Yeah, the three-sided shape. It turns out, this simple piece of geometry isn't just taking up space in textbooks. It's the invisible engine that completely revolutionized how we practically understand and navigate the world around us.
Just think about this for a second. How exactly do you map an entire empire without ever leaving your hometown? Or, before we had orbiting satellites beaming down high-definition images, how on earth did anyone accurately map continents, oceans, or giant mountain ranges? I mean, they couldn't exactly stretch a giant tape measure from Paris to the Alps. They needed a brilliant, practical, mathematical hack to measure the literally unmeasurable.
And that genius hack, it's called triangulation. It's an incredibly clever method that uses a network of connecting triangles to calculate immense distances across land, totally bypassing the need to physically walk and measure every single inch of it. The real magic of a triangle is that if you know just a tiny bit of information, like the length of just one side and a couple of angles, the rigid rules of geometry just automatically reveal the rest.
The mechanics behind it are actually surprisingly simple. Step 1, you measure one single baseline on the ground. That's your foundation. Then, step 2, you take an instrument called a theodolite, which is basically a fancy telescope mounted on a protractor, and you measure the angles from each end of your baseline to some distant landmark, like a clock tower or a mountaintop. Finally, step 3, you just use a mathematical principle called the law of sines to calculate the distance to that landmark. Suddenly, boom, you've got a massive, mathematically perfect triangle. From there, you just keep chaining these triangles together until you've covered an entire country.
But obviously, before the math can do its magic, someone has to put in some seriously tedious physical labor. Back in 1668, the French decided to put this to the test on a really massive scale. A guy named Abbé Jean Picard laid out the very first baseline for a national survey. He spent weeks meticulously placing wooden rods end to end along a flat 7-mile stretch of road right outside Paris. It was grueling, hyper-precise work. But that single, perfectly measured road, it became the key to unlocking the entire map of France.
So Picard and the guys who came after him took that one baseline and expanded it into this huge web of triangles stretching all the way to the Atlantic Ocean. And when all the math was finally tallied up, it revealed something pretty shocking. The western coastline of France was actually 1.5 degrees further east than all the old maps had shown. When King Louis XIV saw this new, highly accurate map, he reportedly yelled, "Your journey has cost me a major portion of my realm." Picard's brilliant geometry literally shrunk the king's empire. But the triangle didn't stop there. It quickly became the weapon of choice in this fierce, international, and oddly citrus-themed scientific rivalry. In the 1700s, everyone already knew the Earth was round, but nobody knew its exact shape. On one side, you had the British, led by Isaac Newton, arguing the Earth bulged at the equator, making it oblate, kind of like a grapefruit. On the flip side, the French, backing Descartes, insisted it was prolate, meaning elongated at the poles, sort of like a lemon. And honestly, immense national pride was completely on the line here. To settle the debate once and for all, King Louis XV didn't just write a sternly worded letter. No, he funded 2 extreme scientific expeditions in 1735. The mission was wild. Go to the ends of the Earth, set up a network of triangles, and measure the exact length of a single degree of latitude. One team headed north to Lapland, fighting blinding snowstorms and slogging through freezing marshes. The other team sailed for the Andes Mountains in Peru, battling brutal altitude sickness, massive mosquito swarms, and deadly accidents, literally risking their lives just to measure some angles.
So what did all that intense suffering actually produce? Well, if the Earth were a perfect sphere, the length of a degree of latitude would be identical everywhere. But the data told a different story. Up in Lapland, near the pole, a degree was 69.04 miles. Down in Peru, near the equator, it was noticeably shorter, at 68.32 miles. Because the distance was longer near the poles, it proved definitively that the curvature was flatter up north, meaning the British were right. The Earth is indeed an oblate grapefruit, and a bunch of triangles proved it.
Now, while the French were using triangles to settle scientific beefs, the British decided to use them to map the absolute crown jewel of their empire. This kicked off the Great Trigonometrical Survey of India in 1800. And guys, this wasn't just a simple survey. It was an 1,800-mile, century-long marathon of pure geometry, a massive commercial and strategic undertaking that incredibly ended up costing more lives and more money than a lot of contemporary wars.
And when I say it cost lives, just listen to what these surveyors were actually up against.
They were dragging massive equipment straight up the center of the Indian subcontinent. They faced intense, punishing heat and the constant, deadly threat of malaria. They were literally hacking their way through thick jungles, absolutely filled with roaming tigers. At one point, their prized instrument, a monstrous half-ton theodolite built in London, was dropped off the top of a massive temple and completely smashed. The lead surveyor had to lock himself inside a tent for 6 grueling weeks just to fix the thing. Eventually, a man named George Everest took over the survey, and he was completely obsessed with accuracy. To make sure his trigonometric measurements remained absolutely pristine, he came up with some insanely ingenious methods. When the flat plains didn't have any natural landmarks, Everest literally ordered his men to build massive brick towers. And to completely avoid the visual distortion caused by the blistering daytime heat haze, he actually made his surveyors work in the pitch black of night, aligning their instruments to the glow of distant bonfires.
And that obsessive attention to detail, it paid off in a way that's kind of hard to even comprehend. When Everest's team finally reached the foothills of the Himalayas, they checked their mathematically calculated position against their actual astronomical position. Over a staggering 500-mile stretch of surveying through brutal jungles and plains, their calculations were off by 7 inches. 7 inches! That right there is the astonishing, practical power of triangulation.
But the most legendary moment of the entire survey came a few years later. The team had been meticulously measuring the soaring peaks of the Himalayas, which was a mountain range a lot of Europeans had previously dismissed as just made-up tall tales. In 1852, the survey's chief computer, a brilliant mathematician named Radhanath Sikdar, burst into his boss's office and confidently declared, "Sir, I have discovered the highest mountain in the world." And this moment brilliantly illustrates the true superpower of this method. They had been targeting a mountain known at the time simply as Peak XV. But here is the absolute craziest part. They didn't measure it by climbing it. The geopolitical situation meant they couldn't even get close to the base. Using a complex three-dimensional network of triangles, they calculated the exact altitude of this monstrous peak from an incredible distance of over 100 miles away. Sikdar and his team furiously crunched the numbers, averaging out readings taken from 6 different observation stations located hundreds of miles apart. And when the math finally settled, the height of Peak XV came out to exactly 29,000 feet. Just a perfectly round, absolutely astonishing number.
But, there was a tiny problem. Fearing that a perfectly round number like 29,000 feet would just look to the general public like a lazy made-up estimate, the surveyor in charge made a very human decision. He didn't want anyone doubting the flawless math, so he arbitrarily padded the result. He literally just tacked on an extra 2 feet to make it look a bit more precise.
So because of that, the official height of the newly named Mount Everest was proudly announced to the world as 29,002 feet. And that slightly fudged number, derived entirely from triangles measured over 100 miles away, stood completely undisputed as the absolute scientific consensus until 1954.
For hundreds of years, triangulation totally dominated cartography. It was first suggested way back in 1533, and it peaked when Britain built thousands of concrete trig pillars all over the country in the 1930s to remap the nation. But then in the 1960s, everything changed. Lasers were introduced. Suddenly, surveyors could just bounce a beam of light off a target and calculate the exact distance using the speed of light. They didn't really need to painstakingly chain triangles together anymore.
Which naturally brings up a pretty big question. Did lasers and modern technology just kill the mighty triangle for good? Is trigonometry basically just a dusty relic from the age of wooden rods, brass telescopes, and colonial surveyors braving the jungle? I mean, you'd probably think so, right?
Well, absolutely not. In fact, trigonometry is quite literally the invisible engine of the information age. Modern GPS, the very thing running the Maps app on your phone right this second, relies entirely on trigonometric ratios. For your phone to calculate its location, it has to receive parameters from at least 4 satellites orbiting the Earth. Your phone then takes that data and instantly runs it through internal tables of sines and cosines to pinpoint your exact coordinates.
The tools have definitely changed, but the fundamental math is exactly the same. We carry the very same tables of trigonometric ratios right in our pockets that those explorers used 200 years ago. From 19th century surveyors braving tigers and malaria in the Indian jungle, to you effortlessly navigating rush hour traffic on your smartphone, the ancient rigid geometry of the triangle continues to practically define the shape of our modern lives.
We've gone from literally dragging wooden rods outside Paris
to communicating with satellites in space, all on the back of a simple three-sided polygon. So I'll leave you with this thought. The next time your phone chimes and tells you to turn left, will you take a split second to thank a 19th century surveyor and their giant wooden protractor? Definitely something to think about. Thanks so much for joining me for this explainer, and keep exploring.